Hello, my name is Ezekiel Lanza, and I am an AI open source evangelist at Intel. As we know, deploying and fine-tuning large language models poses challenges due to their resource-intensive nature. In this video, we will guide you to easily deploy and fine-tune LLMs using BigDL-LLM on Kubernetes. BigDL-LLM is an open source library optimized for running LLMs on Intel XPUs. It utilizes low-bit optimizations for any PyTorch model, ensuring extremely low latency and a minimal memory footprint. Users can build and run LLM applications for both inference and fine-tuning using standard PyTorch APIs like Hugging Face transformers or LangChain. Also, a broad array of models like Llama or ChatGLM have been successfully verified and optimized on BigDL-LLM. Let's start by exploring LLM serving. BigDL-LLM serving provides an efficient and scalable service framework tailored for LLMs on Kubernetes. It leverages fast chat as a distributed serving framework and BigDL-LLM as the inference engine. A fast chat frontend is deployed as a web UI and RESTful API server to serve user requests, dispatch requests, and return responses. Multiple backends are deployed for LLM inference, each utilizing BigDL-LLM as the inference engine to load the model, quantize the model, do the inference, and communicate with the frontend. Here is the process breakdown. A user deploys services, including fast chat frontend and multiple backend workers. Backend workers load encrypted models from the file system and quantize them using BigDL-LLM. Then, backend workers register themselves with the controller to periodically send heartbeats. On receiving a request, the controller is queried to return a worker with the requested model and the shortest working queue. Corresponding worker API is invoked to generate the response, and the user gets it from the web RESTful server. The following is a demonstration of the deployment of BigDL-LLM. First, it's necessary to deploy various resources such as persistent volumes claims, and also the pods that are required for use within LLM serving. Afterward, we can monitor the loading of model files by reviewing the logs of the worker. When using curl to make API calls, corresponding events can also be observed in the worker's logs. Since the worker is deployed as a deployment, we can quickly adjust the number of workers through kubecontrol scale. Finally, by using kubecontrol port forward, we will make the internal UI port of the controller accessible on the public internet. We can now access and utilize the LLM serving functionality through the UI. At this point, we are able to interact with the LLM. After exploring LLM inference, let's delve into BigDL-LLM fine-tuning. BigDL Cullora is a refined LLM fine-tuning solution designed for Intel Xeon processors, employing low-bit quantizations and distributed data parallelism. Utilizing the Kubeflow MPI operator, it automates scalable fine-tuning tasks across pods and services. This ensures precision by effectively synchronizing parameters using Intel libraries like Intel MPI and 1CCL. In Kubernetes, this system helps fine-tuning scale up smoothly without sacrificing accuracy. It also easily saves fine-tuned models for later use, making it a flexible and efficient way to work with machine learning. And here is the operational process. A user submits a BigDL Cullora fine-tuning job to Kubernetes. The Kubeflow MPI operator then manages the task, creating pods and services. Worker pod awaits requests from the launcher, while the launcher pod sends SSH public keys and MPI commands to the workers. Once MPI tasks are received, the rank 0 worker acts as the 1CCL master. All workers load models and data, continuously sending logs to the launcher. Workers being distributed PyTorch operations with 1CCL backend, synchronizing parameters of transformers such as Llama 7 billion through Intel MPI. Upon completion of fine-tuning, the 1CCL master pod stores the fine-tuned model in the specified NFS output destination. And here is a demo showcasing the deployment process of a fine-tuning job. A Helm chart approach is used. We can perform a quick deployment via Helm install after modifying values such as the NFS configuration and model path within the values.yaml file. You can adjust trainer num and CPU per pod based on the number of nodes and CPU cores in your cluster to fully utilize the resources. Different microbatch size settings lead to varying training speeds and loss. Upon successful deployment, you can enter the launcher pod and inspect the launcher.log to observe changes in the loss, for which we also provide corresponding trend curves in the plot. Okay, let's do a recap of the architecture for BigDL-LLM serving and fine-tuning on Kubernetes. Follow the upper section for deploying LLMs using BigDL-LLM serving, and follow the lower section to enhance their fine-tuning with Kullora. For additional information about BigDL, you can refer to the BigDL GitHub repository, where you will find these and other examples. Thank you for your time.